Okay, so look at the next example. So the next example, using double integral to find the volume of the tetrahedron. So do you remember the tetrahedron? How can we sketch the tetrahedron? So the tetrahedron, now we are talking about the example 3. So the equation of the tetrahedron is coming from 4x plus 2y plus z equal to 4. So how can we obtain the tetrahedron? This is about chapter 1. So you have to provide the three traces. So when x equal to 0, so we have 2y plus z equal to 4, or we have negative 2y plus 4. So now the graph is a negative slope. So on zy plane, so at z we have 4, and on the y-axis, you have to replace z equal to 0, and we will get 2y equal to 4, y is 2. So this is 2. Okay, and then now we go to the y equal to 0. So you have to set y equal to 0. So you have 4x plus z equal to 4, and your z is minus 4x plus 4. So when you sketch the graph on zx plane, so you will get negative slope, and at z is 4, and at x, so you have to set z equal to 0. So you have 4x equal to 4, and your x is 1. So that is 1. Okay, and then so now z equal to 0. So we have 4x plus 2y equal to 4. So normally we have y in terms of x, right? So we have minus 4x plus 4, and y will give you negative 2x plus 2. So the graph is then looks like still we have the negative slope, and now is y versus x. So at y it is 2, at x is supposed to be, you have to replace y0, and you will get 2x equal to 2 and x equal to 1. Okay, so now you have to combine all the three traces into a single x, y, z plane. So x, y, z. Okay, so now where is the blue line? Where you set x equal to 0. So you read from here. So your blue line is this one on zy, right? So your intersection at 4, 2. Okay, and then when you are over here, you look over there. So on zx plane, you have the red line, and you can see that at z it passes through 4 at z axis. So that is 4, and x is 1. Okay, and then when you are standing over here along z, you're looking down. So on y-x plane, you have the straight line, the purple one. So at y it is 2, at x it is 1. So it is intersect each other. So we have the tetrahedron. So the tetrahedron is a surface. It is a flat plane, and that is the surface looks like. It is actually open surface, but then according to the instruction here, we need to find the volume. So if you have just an open surface like this, the volume does not exist because it is open. So now it looks like when we read again the instruction, using double integral to find the volume of the tetrahedron, and this tetrahedron is bounded by the coordinate planes. Okay, so the tetrahedron is given by 4x plus 2y plus z equal to 4, and this one, that is the surface, and that surface then bounded by all the coordinate planes. And then did you remember what is the coordinate planes? Remember I give you the question, what is the coordinate planes? So the coordinate planes is the simple sentence for answering the coordinate planes. It is just a wall, front wall, left wall, and the floor. So meaning that you cover, it is open, and then you cover the tetrahedron by the x equal to 0 plane. So this is x equal to 0 plane. So you have something at the back to cover. So this one belongs to x equal to 0 plane. And then this is your front wall. If you're sitting over here, and that is your front wall and your left wall, then you need to cover this one. So that is given by y equal to 0. And then your floor here. So let me change the color. So you have the cover down here, that is your floor. So this one belongs to z equal to 0. So now you have a solid where you can touch it, and it is now closed. So that's why we can evaluate the volume, because it is closed. It is a closed and bounded surface where the tetrahedron is covered or bounded or enclosed by all the coordinate planes. So now we can evaluate the volume. So now what is the formula to obtain the volume? So the formula is using double integral. So we must have the function, and we must have the order of integration, and we must have the region. Okay, so now we want to evaluate the volume, where actually we assume this one to be the height and this one to be the area. So as we know, the multiplication of height and area will give you volume. So now we have to find ourselves what is the function, the integrand here. And after you can determine the function, then you can determine the order. And after you determine the order, then you can determine the limit. So that is the procedure. That is the step. You cannot just mix up everything, then you can get stuck. So firstly, find the integrand. And after you manage to get the integrand, then you can determine the order of integration. And after you determine the order of integration, then you can determine the limit. So after that, you will get a complete double integral, then you can evaluate. So the answer that you have telling you it is a volume of this tetrahedron. But now, how can we determine the height? The function or the integrand here. So in order for us to determine the function, first, you have to look at your solid. Okay, so for the first, something that confusing, but then I'm sure that after that you feel you will get more understanding, and you can get better understanding, and easy for you to determine yourself. Okay, so here what I want you to do is just think you are inside that solid. So now what kind of orientation that you want to you yourself will get insight into the solid. What I mean here is, are you standing like this, or maybe you want to do something abnormal, so you want to just standing like that, and or maybe you want to standing like this way. Okay, the reason why I'm asking you this, because of maybe some of you use a different orientation. So maybe some of you choose this one to be Z, and this one to be X, and this one to be maybe Y, I don't know, because depends on your I mean your understanding, your imagination, right? So maybe some of you will have a different orientation. So let's say, okay, let's say now I'm using this orientation. So my so if I want to, okay, so let's say this is the orientation that I'm using. So the common the common direction of myself when I get into this solid, I will standing like this. Okay, so let's say now I will choose in that direction. So just ignore. Just a second, I have to erase this. So okay, so now that is the direction that I have. Okay, my orientation when I standing inside the solid. So now ask yourself, if you standing like that, and who is your floor? I mean, you should answer which plane that you are. If I'm asking you, where is your floor right now? When you're standing like this, so where is your floor? So then you will see that my floor is on XY plane. Okay, so when you have that particular orientation, so your region is on XY plane. Okay, so region on XY plane. So that's why you have to put the XY for your region. Just to let you know that my region should be on XY plane. That is because maybe if some of you standing like that, or maybe the orientation the orientation of the solid that your friends choosing is a different one, where your floor now on ZY plane. You can see that if you're standing like that, so your floor will be on ZY plane. Then you have to put then your double integral to be like this, and you have to state that your region on ZY plane. Okay, so this is very important because of whether you choose this or this, so the function and the order will be affected. So let's say here you choose X and Y, so your function should be also in terms of XY. So your order also only for X and Y. But if you choose ZY, okay, let's say you choose this direction, so your floor now is on ZY plane, so you state that your region is lying on ZY plane, so your function here should be in terms of ZY. And your dA also, there is only Z and Y, whether you have dZ dy or dy dz. So that is very important. Similarly, if maybe some of you choose your region on ZX plane, where you standing like, where is ZX? ZX. So you standing like, what color that you want to use? You're standing like this. Okay, so your floor now is on over here. So your floor now is on ZX plane. So you have to state that your region on ZX plane or exact plane. Then your function should be also in terms of ZX or exact, and your order should be dz dx or dx dz. Okay, so that's why the first question is, after you sketch your solid, you must determine where is your region. So what is actually your region? Your region is the floor, your floor. Okay, the floor. Okay, so now let's say we back to the standard orientation and the common direction that you are standing on in the solid. So we don't have again, I have to erase this. small people, and also this small people again. And now I resketch. So I resketch. The small people now is like this. Okay, where I'm standing on XY plane. So my region is on XY plane. So this is not part of the answer. Okay, so now, so we have decided that the region should be on XY plane. Then, now to determine your function here. Okay, after you decided what kind of region that you have, so your region is lying on XY plane, so you have to have the function in terms of XY. So how can we get that? So it's coming from the solid again. So to determine the height, you have to determine the integrand here, you have to look at your solid. Okay, so since now you are lying on XY plane, okay, you are standing on XY plane, and then you have to be able to determine your, because this one is supposed to be the X and the Y, right? Or the Y and the X, right? Okay, so now ask yourself, what is another variable is not in the list yet? You already used the X and Y for the area where part of the X. I mean, you can have the X from the dx and you can have Y from the dy. So what is another variable missing here that you don't use that yet? It is Z, right? Z. So Z, you have to determine the limit of Z. So why I'm saying that, so the limit of Z here will tell you the function here. So how can we get the function? So the function is actually okay, so okay, back to the limit of Z. So the upper bound given by Z2, the lower bound given by Z1. So the F is actually the subtraction between the Z2 and the Z1. Then we give you the integrand. Understand? Okay, I repeat, how can you, because the first thing that you have to determine is the integrand. Okay, so, but then before you decided to have the integrand, then you have to determine where is your region on or lying on. Okay, now we said that the region is lying on XY plane. So now we know that it is clear your function should be only in terms of XY, and your order of integration also only belongs to X and Y, so no Z. But then how can we, when can we use the Z? So the Z here will give you, the limit of Z will give you the function. But then how can we get that? So in general, for the interval of Z, the lower bound, I just put Z1. And then the upper bound of Z is Z2. So how can we get the integrand? So the integrand is the subtraction between the Z2 and Z1. Okay, so now from this solid, you can determine the Z1 and Z2. Okay, so again using these small people, which is you inside there. So now ask yourself, when you are standing like that in that solid, imagine who is becomes your floor or becomes your lower bound. Or in Malay, I will say, siapa yang you pijak sekarang? Okay, so you can see that now your floor where your feet is lying on is at Z equal to 0. Because we know that as from the instruction previously that they said that the tetrahedron is bounded by the coordinate planes, which is part of the coordinate planes is Z equal to 0. So now I know that the lower bound of Z is Z equal to 0, which is Z1, right? And then who is covering you? Who is becomes your upper bound? Okay, so I know that most of you will say that Z equal to 4 because you can see the 4 here. But imagine if I put Z equal to 0, we have a flat surface, right? So, and then you can see that we have a flat surface down here, which is the floor. Okay, z equal to 0. But then if you put z equal to 4, it looks like you have the plane, the flat plane z equal to 4 will cover your head. But now, it is not a flat. It is something, there is a slope. Okay, let's say you imagine you are inside a tent. You know tent, kemah? Okay, and then kemah you singit kan? So meaning that your tent is not a flat tent. Okay, so just like a triangle shape. So if you say that your tent is as you can see here, it is not flat. But if it is z equal to 4, then you should have the plane like that. But it is clearly seen that there is no such plane z equal to 4. But it is something part of the tetrahedron. Do you agree with me? Understand? If you put z equal to 4, it is incorrect because you cannot see this kind or this such plane from your sketching. So you cannot put z equal to 4. What can I say is the surface who is covering you now is part of the tetrahedron, which is something like triangle shape. Okay, then what is the equation of the tetrahedron? It is given? Yes, it is given. So the tetrahedron is given by this one, but because of you want this z, you just want z, so you have to rearrange this to be just z equal to. So if the original one, I mean the original expression is for x plus 2y plus z equal to 4, then you have to rearrange that to be z equal to 4 minus 4x minus 2y. So the correct answer for that is now your z, your cover or becomes your upper bound is part of the tetrahedron, which is 4 minus 4x minus 2y. So that is the limit of z. Okay, so now we back to we already obtained the z1 and z2. So the z1 just now we got 0, right? And z2 is 4 minus 4x minus 2y. Okay, we already get that. So now we put the z2 minus z1. So z2 minus z1. So z2 is 4 minus 4x minus 2y minus z1 is 0. Then your function is 4 minus 4x minus 2y. And as you can see, is your f correct? Then we should check. So as we know that our region on lying on xy, so our function should be also in terms of only x and y. So that is correct. So it is matched. Okay, you cannot, if you have your r lying on xy, but you put your function here is in terms of yz. So then when you want to evaluate, then we'll get a trouble. You can get a trouble. You cannot integrate them because for double integral, the variable that we have only two, xy, or maybe you have yz only, or maybe you have xz only. You cannot have three variables at the same double integral. Okay, so hopefully you understand that. Okay, so now we already obtained the integrand. So now we substitute the function. The integrand is 4 minus 4x minus 2y. Okay, over the region, and the region lying on xy plane. Okay, so now how about the dA? So how can you find the region? Where you can find the region? So as I mentioned just now, your region is something that you are standing on. So you are standing on the xy. So, okay, so maybe you might wonder, okay, my answer, if someone asking me, how can I determine the region? Okay, firstly, you have to decide which region that you have. Okay, in this case, I'm choosing in this direction. I'm standing like this, so my region on xy plane. Okay, so now I'm asking yourself, if you are standing along the z, you are standing over here along the z. and when you are looking down, so what is the dominant shape on XY plane that you can see? I repeat, when you are standing along the Z, because why I'm standing here, why don't I standing over here? Because just now you said that your region on XY. So meaning that when we go to the tracing before this, how can you have the XY plane when we set Z equal to some values, right? Which means that you are standing along the Z. So when you are standing along the Z, what is the dominant shape that you can see lying on XY plane? Okay, please tell me. Then I cannot hear you, right? But I am sure that you will see that the dominant shape that you can see is part of this triangle. So how can you get it from your tracing? So it is on XY plane, which is this one, right? So that is your region. So your region is in this shape where on YX plane. Okay, so that's why I'm telling you that even though from the instruction here don't mention about the tracing, but the tracing sometimes will help you to determine a correct calculation or the correct limits or order of integration. Okay, that they are very important. Okay, so now you can see that they are actually the same, right? This one and this one, they are the same, but just different orientation. So this one on 3D and this one in 3D. So your region is inside here. Okay, so in order for you to determine the order of integration and also after that limit, then you have to look at your region. So your region is basically part of the equation of this one. This one. Okay, so what kind of order do you want to use? dy dx, x constant or y constant? Okay, so just look at your integrand. We just have a simple polynomial. I'm sure that we have no problem to integrate x first or y first. And then look at your function here, just y in terms of x. So for me, I will choose x constant. Okay, so I'm choosing x constant, which means that I have to provide the vertical line to help me, to guide me to determine a correct limit of x and y. Okay, so since I'm choosing dy dx, so here I put dy dx. So now we want to obtain the limit of x. So the limit of x and the limit of y. Okay, so you can see that based on this line, the x is between, this line is between 0 to 1, and the y should be, that is the lower bound, and this one is the upper bound. So the lower bound is given by y equal to 0, and the upper bound is coming from the line of this, where your upper bound is 2 minus 2x. Because we know that this is the graph. So now we put the limit x is 0, 1, and then y is 0 to 2 minus 2x. So now we have a complete double integral. Then we can determine the volume. Okay. So next we have to integrate respect to y. Not x but y. Okay, y equal to 0, y equal to 2 minus 2x dx. Okay, so this look a bit messy. Okay, so for y, 2 minus 2x minus 4x, and then y, 2 minus 2x minus 2 minus 2x square minus 0. So just see. So we have the terms that are in terms of x, and you have to expand and then simplify. So be careful, this is not This is not so complicated, but tedious. Four minus 4 plus 4/3 minus 0. So we get 4/3 unit cube because we are computing the volume. So now we manage to get the volume of this tetrahedron. Okay, so as a practice, maybe you can imagine you are standing not in that direction, just for practice. Okay, so you are standing like ZY. Okay, so your region now is on ZY. Okay, which means that, just for practice, so your function is in terms of YZ. So your dA also in terms of YZ, and because of your R now is on YZ plane. Okay, so your function should be because now you have the YZ, so and then now ask yourself, what is another variable is not still not used here? You already used the Y and Z, so you cannot see the X, right? So the X is not here and also here because it should be the same. So meaning that the function here is depends on the X, where the X should be the X2 minus X1. X equal to where your X, your X here should be, then becomes the function of Y and Z. How can you get that? From the tetrahedron equation here, okay, and then you have to have X equal to, you have to modify, so you will get X is the function of YZ, then becomes 4 minus 2Y minus Z divided by 4. So that is your X now. Okay, just practice, and your final answer should be also the same, which is 4/3.